Okay, so today's lesson is all about food chains versus food webs. How are they different? Why do we even have two different terms for them? So, the driving question that we're trying to answer today is why are food chains limited to 3 or 4 levels? Why aren't there 17 levels? So, to go back to review what we did yesterday we started out talking with the difference in between producers and consumers. Producers, another word for that, is an autotroph. Auto, automatic, troph means to eat. So a producer is literally an auto eater. So this would be something that goes through either photosynthesis or chemosynthesis, where we talked about the very deep, deep bottom of the ocean. And then we talked about consumers, which are called heterotroph. Hetero means other or different, and then troph, eater, meaning that they cannot go through photosynthesis, they cannot go through chemosynthesis, they have to eat something like us. We are consumers, we have to eat. Okay, so taking that into today, we start out the bottom of a food chain with our autotrophs. So we could talk about grass being our autotroph. Well, then our next step above that would be what eats the grass. So if we're talking about the movie The Lion King, since we talked about that last week, what is it that would eat the grass? Would the antelope eat the grass? If so, then it would be one step above the grass in the trophic level. And trophic level is another important term, and it literally means where it is transferring the energy. So when you're drawing your food chains and your food webs, make sure that you draw your arrows pointing up towards what is getting the energy. Because if you were to draw it backwards, that the antelope was giving energy to the grass, then we would have some pretty strange grass that is eating antelope. Okay, then we take it up another level. Then we draw another arrow up in the food chain to what then eats the antelope. Well, didn't Simba say that they eat the antelope? Perfect, he does. So then right above the antelope, we could draw an arrow upwards towards Simba. So then we have a food chain. How that is 100% different than a food web is that it is just a chain. Think about a chain link. It is linear. It doesn't go any crazy directions. It is just up and down, sideways, sideways. So it is one option of what something eats. So if we're talking about Simba, Simba obviously eats more than one thing because he may find an antelope one day. He may find something else the next day to eat. So the food chain is the linear relationship between it and the antelope and then the grass. And then we always, always, always have to link that back to the sun if it is a normal scenario and not the cave or the bottom of the ocean. All right, now switching to what if it was a food web? Food webs are the real life what would happen, because it's not real life to just think that one organism only is relying on one other one for food. Simba doesn't just eat antelope. He likes a different diet. So a food web is a very complicated, convoluted relationship of everything that could possibly eat everything and who's getting which energy. So when you draw a food web, is it supposed to look crazy? Yes. Yes, it absolutely is. So your food web that you're drawing today in your notebook should look crazy on purpose because it shows the more real life. Everything is connected, just like in The Lion King where it says the circle of life. So in a food web, you have to think not only that the antelope eats the grass, well, what else could eat the grass? And then you draw arrows up that way. Then when you get to the antelope, you have to think, well, what else could eat the antelope? Is Simba the only one that eats the antelope? No. There are other things out in the wild that could eat an antelope, so you then have to draw those arrows. The real key factor here, and the whole reason why we're talking about this, is to understand that everything is truly connected. So we're going to take this as a jumping off part for tomorrow of talking about, well, what would happen if one thing in this chain were to collapse? Would everything be affected? Duh, yes, everything would be affected. So as you go through the assignments today, really think about that. Really think about, well, what would happen if this antelope were to disappear? What were to happen if this giraffe were no longer here, if it just spontaneously went extinct? So your other driving question for today is related to the law of 10%. So if we take one of the examples of a food chain and then we stack it up in a pyramid format, we have the producer down at the bottom, and then we have at the very top of it our top consumer. So it may be a hawk. So we put the producer down at the bottom, and every time we step up, the organism loses 90% of the energy that it consumes, and it only keeps what? 10%. So this is the law of 10%. So the easiest way that you can think of it, if I ask you numbers, is that you lose a zero every time you go up.